Hey guys, welcome to Safi Mixed. In this video, I will let you know about the application of f function to construct delta function and to use it further to construct a set of Pauli matrices. So this in fact seems an easy task, but this will give you an intuition for the application of f function in programming with Mathematica. So first I add the clear or global function, and then I first construct a function of two variables I and j such that it is delayed function, and I use the f function because since we know f function takes three entries into its argument, so I define the first entry as a condition on the parameters I and j, and I ask the f function to give 1 when they are equal and 0 when they are different. So this is a function, and I run this function, and if I check the values for this for different values of I and j, for example, I set I is equal to 1 and j equals 0 and check the output, it gives me 0. And similarly, if both the entries are zeros, it gives me 1, or both the entries are 1, it gives me again 1. For whatever choice of the entries I and j, however, if they are same, it will give me 1, and if they are different, it will always give 0. So that's the property of a delta function, and we have constructed the delta function. Now I want to use this delta function to construct identity matrix. I can do that by defining IDN, a function, IDN, and as a table of the function f I and j, and I give the set of values to I and j to start from 0 and 1. If I do this, this will give me a 2 cross 2 matrix, and j from 0 to 1, and I define and I fix its value. So I assign the output of this table to IDN. If I check IDN, and I can see that, oh, there is something wrong. If I check, yeah, I haven't put a comma after j, so let me redefine this and then run IDN. So this is a 2 by 2 matrix, and I can put this into matrix form to check properly. I can give any order by changing the values of I and j. For example, I set this equal to 2, I'll get a 3 cross 3 matrix then. Right, since this is a 3 cross 3 identity matrix, I can construct any order of density matrices, but for the time being, I limit this value to only 2 cross 2 matrices. So this is this in fact is an identity matrix for a two-dimensional space. I can construct Pauli X matrix from the same eigenfunction by again redefining the same thing. I copy this from here and I paste this over here, and I change the entry to 1 minus the function. And if I run this and then check the output of this, I can see that this in fact is Pauli X matrix. You see, this is Pauli X matrix. So we can use the delta function to construct Pauli X matrix or the identity matrix, but we cannot use this delta function directly to construct the other two Pauli matrices, that is Pauli Y matrix and Pauli Z matrix. In order to do that, I redefine another function, which I write it as g as a function of two parameters I and j, and I again give this a delayed function, and then I enter the f function, and I construct the conditional part of the f function as I equals 1 and j equals 0, then give me iota. And at the second output of the f function, I put another f condition or f function and put the condition I equals 0 and j equals 1, give the output as minus iota. And if these conditions are not satisfied, give me 0. So this is a function through which we can construct the Pauli Y matrix. I read this to Mathematica and then define Pauli Y equals, I copy the table from here and I put it over here and change the function from f to g. And I run this. And now if I take Pauli Y matrix form, then I'll get so this is Pauli Y matrix. Similarly, I can construct a function from the f function to define the z operator, and I call that function is h, and I change the conditions here that if both I and j are equal 1, give me minus 1. And if both I and j are equal 0, give me 1. And for other entries, for other combination of I and j, produce 0. So I read this to Mathematica and then construct Pauli Z operator as a table like this one. So I copy this, put this over here, and I change the function g to h, and I read this to Mathematica and then check the form of Pauli Z matrix, and I put the matrix form, and you see this is now Pauli Z matrix. So we can construct too many things if we know the application of f function. We can construct delta function, Pauli matrices, and too many other things. I can put all these matrices into a single entry. For example, I can construct a list in the form of list. I for list equals identity, then Pauli X, then Pauli Y, and then Pauli Z. I enter all this and I define this matrix, and then I construct a function polymat, and I call this n function of n, delayed function equals list n. And I define this. Now I can extract any matrix polymat from this. If I set n is equal to 1, this will give me identity matrix. If I set Pauli argument 2, it will give me the x function, the Pauli x matrix. 3 will give me Pauli y matrix, and 4 will give me Pauli z matrix. So this way you can construct the Pauli matrices and the delta function through the f function. Thanks for watching.